Hello, everybody, and welcome to the Emerging Technologies Information Sessions 2025 webinar series. We are now in week 3 of the webinar series, and my name is Sam Cimino, and I work for the U.S. Geological Survey and the Pacific Northwest Aquatic Monitoring Partnership. And over the last year or so, a planning committee has been putting together this ETIS webinar series. But we didn't start from scratch. The Pacific Northwest Aquatic Monitoring Partnership and the Pacific States Marine Fisheries Commission's StreamNet program have been hosting iterations of these emerging technologies conferences and webinars for more than 15 years now. And so the aim of the Emerging Tech project is to bring together monitoring professionals and project managers and data managers to showcase how they implement the latest technologies in aquatic monitoring. So we're already in the 3rd week of this webinar series, and we'll continue for 2 more weeks with these 2-hour sessions that are every Wednesday from 9 a.m. to 11 a.m. Pacific time. And I know a lot of you guys are coming from Mountain Time today, but just adjust accordingly. And so today's session is all about data QA/QC, and these sessions are all being recorded. So if you miss the modeling and analysis session or the artificial intelligence and machine learning session, you can check out those recordings on the PNAMP YouTube channel. And these are typically available within a week after these sessions. So look for it by the end of probably tomorrow. And now I'm going to kick this over to our moderator today, Evan Brown.
Morning, folks. Can you hear me okay, Sam?
Yeah, I got you.
Cool. Okay. Hey, my name is Evan Brown. I work for the Idaho Department of Fish and Game. I'm the IDFG StreamNet data coordinator, which means that I deal with a lot of large data sets and do a lot of QA/QC. And so this session about data quality assurance and quality control is very near and dear to my heart, as well as a bunch of other folks on this call. And specifically, we're going to have 3 presentations that illustrate how using a mobile app to collect, compile, and access your data can increase both the quality assurance and the quality control and the access to the data. With that said, a little bit of ground rules here, and most of you are probably familiar with them already. But if you have questions, please go ahead and raise your hand, or just enter them into the chat. We have a couple speakers who are on pretty tight timelines today, so we may not be able to get to all the questions, but rest assured we will have contact information and we will be able to get questions to them and get your answers back. With that said, one other thing, please leave your cameras and your microphones off unless you're talking. And with that said, I think that brings us back to the first presentation. Justin, are you here? And ready to roll?
Can you
are.
Hear me?
You bet. Hey, folks, this is Justin Welty. He's a biologist who has spent the last 16 years working at the USGS Forest and Rangeland Ecosystem Science Center in Boise, Idaho. He designs and helps to manage multiple national level databases, including the Land Treatment Digital Library, Conservation Efforts Database, Rangeland Monitoring Project. We need more acronyms. And Early Detect and Rapid Response Environmental DNA Laboratory Information Management System. See what I mean? He is also considered one of USGS's leading experts on ArcGIS Online, Survey 123, and field maps. And not working just to enjoy spending time with his family, woodworking, nature photography, and fishing. With no further ado, I'll turn it over to Justin.
Thank you for that introduction, and let me share my screen here and make sure everything's working properly. Can you see the presentation, and is it the correct screen?
Yeah, we can see it. Thanks.
Excellent. Well, thank you for that introduction, and thank you all for attending this session on data quality assurance and data quality control. I want to start by acknowledging and thanking my co-authors, Michelle Jeffries, Robert Arkle, and Jackie Couples. The project I'm about to talk about is really large and complex and requires a really substantial team of contributors and collaborators, including way more than I listed here, in order to pull it off successfully. Now I got to get you to advance to the next slide. There we go. So generally, in USGS, we do science for partners. And when we're working with partners to design monitoring programs, we want them to figure out the questions they want to answer. And it's those questions that drive our monitoring design. And to begin with this talk, I want us to think about the data life cycle. And I want you to think about how you interact with your data. A typical data lifecycle, something we've often done in the past, starts with field season prep, including a quality assurance step to help prevent errors. It's followed by the field season where we're collecting our data. And then at the end of the field season, we try to run a data quality control step to fix or remove any errors that occur. Then we conduct our analysis using a variety of programs. And finally, we write our report or peer-reviewed publication. If it's a multi-year program, the cycle begins again at the start of the next season. And so we just do this over and over and over again, usually in these set steps. And I want to try to encourage us all to break out of this traditional cycle. And I do that by removing data quality assurance and control out as an individual step in the process. And instead, I propose that we take advantage of all the new technologies we have at our fingertips to make data QA/QC an integral part of all our steps. And we can help make this an idea a reality by using a lot of new data visualization technology that's at our fingertips. That's easy to program and easier to use than traditional coding, and allows us to interact with our data in ways that make it easier for us to prevent, identify, and fix errors. And for this talk, I want to explore the data lifecycle of two different programs we're running. The Rapid and Other Methods for Assessment and Monitoring, or ROAM program, and the Rangeland Monitoring Program, or RMP. And as you probably heard in my introduction, I live in a world of acronyms because of the long names that all my projects tend to have. However, you can think of ROAM and RMP as two sides of the same coin. The ROAM program consists of 15 different monitoring protocols, including cover estimates, density estimates, and observational data, all being collected on the same plot. It takes our crew of 4 about 9 hours to collect all the data on a single plot. The goal of ROAM is to look at and compare collection times and value of the data collected to help inform users about the best and most efficient monitoring protocols for a given question, with the hope of maximizing the number of plots that can be collected and minimizing the amount of time, which is something we're always trying to strive for. Excuse me. RMP is the implementation of this practice, where we have individual groups across the West that utilize their own subset of these protocols to help answer their specific questions. The RMP program has been going on for about 3 years now and continues to grow. We've got national, state, and local participants from a variety of groups in Oregon, Nevada, and Montana. And I'm not going to go through all the names there, but you can see the list. And we've got more states likely coming online in 2025. Last year alone, we were able to monitor 1,600 plots across the West in those different points you see on the map here. And those different points represent different kinds of plots. Part of the power of the RMP project is that we allow each group to set their own defaults and own protocols so they can customize their monitoring to fit their exact needs. However, all that data that's being collected is still then submitted to a single centralized platform. So all the data end up in a single location, allowing us to combine data and compare apples to apples instead of apples to oranges. So now that we've talked about the program, I want to get into our QA, QC, and visualization steps. And the next question I want us to explore is how we can protect our data integrity during data collection. For most of us, this starts with the field collection apps. Traditional paper was a common source of error, both when writing it down and again when transcribing it to a digital format. Most of us now use and are familiar with digital data capture technology, and many of us use the Esri, ArcGIS, Survey123, and Field Maps apps. And so I want to explore how we're using these in these two programs to help prevent and detect errors. So Field Maps is our initial step in defense of data integrity. With so many groups collecting data, it can be easy to get confused. We utilize map styling and symbology to help display layers at appropriate scales. In addition, users can filter points to only show the data they're responsible for monitoring. We also utilize pop-up windows to lay out the data in an easy to read format. And so you can see when I click on the point here, it's going to pop up a pop-up window that has some of the most critical data at the top, some links that will open specific Survey 123 forms in the middle, and additional data down below that they can get to if they need it. Now, you might notice that the Survey 123 links don't appear in this case. We want to force users to enter data into our Field Maps app before they can access the Survey 123 fields. So we really want them to enter the monitoring status. Did you monitor it? Were you unable to monitor it? Was it not monitored for some reason? Once they choose this in the Field Maps app, it allows them to then continue on to Survey 123. However, they can update other fields as well. If the monitoring team changes, for example, from what was set as default, sometimes we have other users going out to monitor a plot because conditions change or time change. It actually updates the survey and form they're using on the fly. It used to be that I had to go in and make all those updates manually. This is a much faster and more efficient way of allowing these custom changes to occur on the fly using arcade expressions, again, to help prevent these errors that tend to creep into the data by forcing users to do what we need them to do. Once it's updated, you can see the symbology on the map has changed from a red star to a gray circle, indicating the point has been monitored. And once this layer is synced, all devices that have that map in sync with the master layer will have that new symbology. So there's no confusion about which points have been monitored and which ones haven't. In addition, the pop-up window has changed. Custom links appear, allowing you to click on a specific form containing the monitoring protocol we want you to run. I clicked on the Windows link because I'm on my Windows computer here, and I use that Windows link that will open a specific Survey 123 form and allow me to fill in default values for me. Field Maps has one other feature we want to highlight, and this has more to do with on-the-ground data quality assurance. So we try to have around 20 points per treatment on most of our plots. And we've heard from users there's still a lot of heterogeneity being missed on the landscape. So we built in this rapid point and polygon capture capability into Field Maps, allowing users to capture an invaded grass or noxious weed patch, a successful area within an otherwise degraded site, or a change in ecostates. This rapid capture only takes a minute or two, but can provide valuable information to resource managers, informing them where to target resources to stop invasive spread or to protect successful areas that might otherwise be missed in our random monitoring design. This next field season, we're hoping to take advantage of some auto contact techniques so that when an invasive or noxious weed point is created, it automatically emails the weed specialist for that area so they can be immediately notified and take immediate action to help destroy those invasive or noxious spots. Okay, let's jump to Survey 123. The original Survey 123 form I designed for this project with 15 different protocols has around 2,000 lines in the Excel template to create the form. It's a massive form, and it turned out to be rather slow and often crashed frequently. To combat this and make life easier for our users, we created individual surveys for individual groups. This allowed us to program each survey with the user-specific protocols and defaults that they used, while removing any information or protocols they're not using. In the case of Rome, we simply split the survey into 2 forms since they're using all the protocols and I needed to split it or it was going to work too slowly. These smaller surveys are much faster, more responsive, and highly adapted to individual group needs. However, the data, again, are still all synced back to that original feature class I created, allowing, again, these highly customizable forms, but a single centralized data repository. Each form auto-populates as many fields and defaults as possible. We're trying to minimize the amount of data a user has to fill in. And a new user request that's going to be available for this upcoming field season is the ability to not only utilize our existing randomly generated points on the landscape, but to create new non-random points. This allows our users to conduct a full monitoring plot in an outlier area or other spot where they think monitoring would be useful. The point won't be included in our overall analysis of the landscape, but it's still important local knowledge, and we want to make sure our users can capture that information. So we set up these forms to walk users through their specific protocols. We've added protocol instructions, including photos and demonstrations directly into the form. We have specific tips throughout the form to help users review their protocols. Each protocol, again, is defaulted to a group's specific needs and requests. However, despite all this defaulting and filling in, users can still change these values if they need to, allowing for, again, easy survey completion in the field, but also customization on a plot-by-plot basis if needed. It allows us to accommodate a very wide variety of needs for specific groups. And finally, each different protocol has a review section at the end of it, allowing users to expand this section and review the data in a simpler format and look for and correct any errors they notice before data is submitted. And while errors still can and do occur, all these steps have allowed us to greatly reduce the number of errors that make it through to the final data set. So we use Survey 123 and field maps to help with quality assurance and a little bit of quality control. But now let's switch gears and talk about how we conduct our quality control, finding and fixing those errors that make it through our initial quality assurance steps. The first of several steps we actually take to conduct our QC is our in-season dashboard. This is an ArcGIS dashboard that is not only used to help identify errors, but our different groups use it for general project tracking to keep an eye on how much they've accomplished and how much they have left to do. So the dashboard, which you can see here, consists of 3 main sections. The section I'm demonstrating on the left are counts of different forms, so we can see how many of each protocol have been submitted. What I'm going through now is also some fun numbers just for them to see, including 6,400 photos taken. That middle pane I was just at is the map and raw data. And this pane I'm demonstrating on the right is a bunch of figures and image information. So you can see here, I'm going through some of the photos that we've taken on the site. And you can see a lot of different ways I have, or different figures I have, allowing them to look at their data in a variety of ways. This one I'm demonstrating right now is one of my favorites. A big issue when identifying vegetation out in the field is unknown plants. Even the best plant identifiers, and I am certainly not one of those, can't identify every plant they see out in the field. So we allow them to take a photo or multiple photos of the unknown plant, record it as an unknown, and submit that data. Then we have this form set up where they can go in and look at all their unknown plants, use the photos, quickly identify them, and then we use scripts to update that unknown plant species code across all tables within the plot where it was recorded. So once we figure it out, we can easily update that to the correct species code. So we can identify errors in our data set using the dashboard. However, Esri dashboards have minimal data edit capabilities. We need a way to fix or at least identify and exclude any errors and document what was fixed or why a data point must be excluded from the analysis. To do that, we created an editable online ArcGIS online web map that's available to all our collaborators. Users can filter data using any attribute they choose. In this case, I filtered by project ID, and the map removes all but my specific points. I can zoom in to look at those points now. I can click on a point to look at the pop-up menu, and I review a summary of that particular point to see what protocols were done and what weren't. And then I can edit that point. And the edit button, again, has access to all the tables and child tables associated with that plot. In this case, let's say I need to update a species in the species inventory. I can drill down. I can edit that specific species or its growth habitat, native status, whatever I need to do, and update that particular record. I also have the capability to add new records, to jump around between records, to delete records if we need to. Most of the main delete function is kind of restricted, but we do allow users to delete individual records if needed. Finally, we want users to document these edits or unfixable data by documenting changes on the main parent table. We have a couple fields where they document what the original value was, what they changed, and why they changed it, so that we keep a record of all edits made to a plot. Again, part of this QA/QC process. A second way we actually go through and edit data is through ArcGIS Pro. It's really nice with these ArcGIS online features. You can bring them into Pro and work with them as if they were a local layer. And this generally occurs when we add new fields or want to do a batch update, and this is usually something that I end up handling. But Pro has multiple advantages over the online map when it comes to these massive QA/QC updates. I can quickly see all the tables in the data set. I can use things like select by location or select by attributes. In this case, I'm selecting by state of Nevada. And then I can use different expressions and field calculator to run batch updates of fields if I need to. And this can be an incredible time saver when we're needing to make an update or when we find a mistake that users made over and over again, and we need to do a quick correction on that. The final way we update data is through a custom Python script. The script took me a while to get right, but it's fully customized to our most common sources of error we see in the data set. So it has a lot of advantages because it's designed to fix exactly what we need to be fixed. The two main uses I utilize it for are to update incorrect or unknown plant species codes across all tables where they recur. Again, talking about those unknown plant codes again. And to update a set of shared attributes we use for filtering and display across all tables. So things like plot ID and treatment ID and project ID and plot type occur in every table to allow the dashboards to filter better. And what we've set up is a user only has to fill in that updated plot ID or treatment ID once in the parent table, and the script will go through and make changes across all the child tables. And given that there's 40 potential tables, that's a lot of effort we've taken off the user's backs. All right, so that was a lot of QA/QC. And now I want to get into some basic reporting, which again is another step in the QC process. So one of the main issues users have with USGS data is that it takes us a while to publish our data. We conduct many additional steps before publication to make sure the data is of the highest standard of quality, but this generally takes a lot of time, especially since reports generally aren't written until after all data have been collected. And we've discovered by talking to our users, sometimes they need to see preliminary data, even if it's not perfect, to make real-time decisions on when to retreat and intervene. To help with this, we've created an in-season summary point feature class and map. This in-season summary is generated again by a Python script, and it's run weekly throughout the field season, so we keep adding new information to it. So instead of having 40 tables all joined together in various combinations, it creates a single point feature class with one row per plot. Not all the data is included, but the summary still contains a wealth of information, including the plot level data I'm showing here, the species inventory combined into a single field, our ocular estimates that our users have collected, all the eco state information, so we get a general idea of what the plot is like, all of our erosion indicators, our LPI and density detailed plant data, And you can see some of these rows are emptied. LPI and density are not collected at every plot. And so where it's not collected, we just leave those rows blank. This single file summary has some amazing capabilities, especially when you combine it with the graphing capabilities in an ArcGIS Online web map. We can create custom figures, as I'm demonstrating here. I'm creating an XY scatter plot. I'm putting sagebrush on the x-axis and annual grass on the y-axis, and to no one's great surprise, as cheatgrass and other invasives go up, sagebrush goes down, and vice versa. And this is a pretty nice figure I made within a couple minutes. But what's really cool is that's an interactive figure as well. So our users can go in and select a set of points they're interested in seeing, and then they highlight on the map, allowing you to see where they are. You can also filter by extent, which I'm doing here, which allows me to zoom in to a particular area. In this case, I'm going to zoom into our Montana plots, and the figure again updates for those specific areas. So our users can create custom figures on the fly, again, to meet their specific needs, and then continue to interact with the data via these web maps. They can also save these figures so that they stick around and become available the next time they open the map. So as more data are added, the figures continue to update. They can also create box plots and any kind of other figures. So in this case, I'm creating a box plot looking at sagebrush, invasive annual grasses, and native perennial grasses. And in a little bit here, I'm going to filter, or excuse me, subset by plot type. And what's really useful about these in-season summaries is not only do they get access to their preliminary data, but it also, again, helps them look for errors and outliers and anything else that might be missing within their plot. Again, allowing them to go back and make changes. And when they make changes, again, a week later, we rerun this, and all those changes will be reflected in the new in-season summary. All right, now let's talk about some annual end of season quality control. And to do that, we use Tableau Prep. And this is our final data QC step before official publication. Tableau Prep is a paid license in the USGS, but the program is well worth it because it's an easy way to combine, clean, and shape our data efficiently. It provides a simple but thorough graphical user interface for users to connect with and can connect to almost any kind of data that we need. This is an example of the post-processing for the roam field data. There are steps to look for errors, reshape the data, add attributes, and export it out into a format that works best for visualization. So it's just a zoomed in figure of the steps, just showing some of the multiple ways we work with our data, including joining different tables together, pivoting the data, creating unions to stack data, as well as aggregations. And again, I can't stress this enough, 40 different tables is a lot to try to keep track of. And probably only Michelle and I are the only ones who can actually do it with any kind of efficiency. And so programs like this allow us to more quickly get the data in a format that's useful for our users. When you're working in prep, it actually allows us to visualize and review the data, notating any changes that we make. And when you click on a step, it displays the data columns and data rows, including in a little histogram you can see there showing the number of values of that particular record. So here on the left, you can see a review of what we've been doing. In this case, we're doing some calculated fields. Again, here you can see the types of data and the values that exist. Again, you can interact with the data. If you notice the blue, those are highlighted rows, and those highlight across all the other columns. So we can see what's been highlighted where, makes it much easier to filter, clean, group, and split our data to get it ready for final publication. And when the final data set's ready to be distributed to the public, we do it in two ways, through a public Tableau dashboard that we're still designing and a public data release. So Tableau allows us to create highly interactive and visually appealing dashboards with statistically relevant figures. The mapping capabilities aren't quite as good as ArcGIS web maps, but the filtering, graphing, and statistical capabilities are superior, which is generally why we go with this for our final products. That's a prototype of what the final dashboard will look like. You can see it has full hover over filtering capabilities, lots of ways to allow users to interact with data, ability to expand data to see more in more detail. We've got different types of charts throughout this dashboard, as well as an interactive map And all of these things work together, where selecting data in one part of the dashboard will highlight that data in other parts of the dashboard. So it's a great way to allow users to see and interact with data in a very visual appealing medium. This is an example of a published dashboard that we've created, but you can see we provide help documentation to users directly in the dashboard, allowing them to see how they should be interacting with it. And again, you can see some of the quality and quantity of the data that we can provide by doing specific hoverovers that then update charts. Again, doing stuff very on the fly, very easy for the user to interact and drill down to exactly what they need to see. And in addition to the dashboard, again, we also plan to do this full public data release. And at USGS, we really strive to release only the highest quality of data. And so these are the steps we take and why it takes us so long. And I think these are good goals for us all to achieve because it creates a really nice data set. We do an independent peer review, full metadata, ability to control what is released. So we do collect some private lands data. And so we are not releasing that. And it depends on the individual data sharing agreements we have with the different users. We make sure the public has full access to what we can release. And so that allows you the ability to download and work with the data on your own if you need something more than what's available on the Tableau dashboard. And it creates a permanent record that's accessible into the future. All right, just about done here, which is good because I'm just about out of time. And I want to wrap up by talking about some lessons learned implementing this project. And adaptive management is often a favorite buzzword. I still hear it being thrown around all the time, but I want to talk about adaptive form management. We should never create a form and just continue to use it and let it sit there and not continue to make it better and better. So we work hard to make sure our collaborators feel valued and heard on this project and really any project I try to work on. I believe that folks doing the actual work know more than the designers. Therefore, we conduct annual feedback sessions to learn about what worked, what didn't work, and ideas for improvement. And in fact, I just got through 2 of these sessions with the Oregon folks and then Nevada folks last week. We conducted feedback sessions, and it's a great way to learn what's working really well, as well as areas that we need to improve for next field season. We conduct annual trainings. This allows us to review and calibrate every year. You can see the photo on the right there is from our Oregon training session this past spring. It also gives us a chance to introduce all the new features that we've added, and we continue to add new features every year. And I believe listening and adapting the forms are critical. And that means I can't have thin skin. I need to embrace criticism. And I can encourage anyone who's designing forms to do the same. You want your users to feel empowered and to feel comfortable sharing feedback, even if it's negative feedback, because that's how you make a form that users actually want to use. And some final lessons learned. The newer technology we have at our fingertips can and should change how we interact with our data. We should not stick to that old cycle of how we work with data. A lot of this technology is drag and drop. It means the learning curve is decreasing, minimal programming skills are required. You can start to stand this stuff up without having this vast knowledge base at your fingertips. Everybody makes errors. From the software that we use, Survey 123 field maps have bugs in them. I have to file a fair number of bug reports. The form creators, I have made multiple mistakes creating forms, and the field crews, the data analyzers, nobody is perfect. We should never assume there's no error in the data, or that this thing can't make an error, or that thing can't make an error. We should always anticipate everyone will make errors, and we should always be willing to watch out for them and to report them when they occur. Never assume anything is perfect, because that's when you get yourself into trouble, because that's when the software will let you down, or the designer will let you down, or the field crew will do something you totally didn't expect. And if you're not looking for it, you can easily miss it. Working together, we can centralize data from the beginning. So remember, all these different groups across the West They're using different protocols. Those protocols have different defaults in them. But because of the way we designed these forms, all that data, despite those differences, are still being collected in a single centralized repository, allowing much easier comparison across the entire rangeland landscape, rather than having to try to squeeze different comparisons and manipulate them to try to make them work together. One size does not fit all. Depending on the questions you have, the personnel you have, and the funding you have, you will not be able to make everyone do the same thing, and nor should you. We should listen to our users' needs and work with them instead of trying to force them into a single application. And waiting till the end is no longer your best option. We are conducting QA/QC throughout the field season as soon as data start being submitted. And one of the things I heard in our feedback session last week is because we have that in-season dashboard, one of our users was able to capture a field user error within the first week, then correct it using our web maps, but also communicate that to their field team and fix it so that it only lasted a week, and then it was correct the rest of the field season, instead of waiting till the end, discovering it, and then having to go back and fix all their data. And the feedback from users on all this has been incredible. They really love having all these options at their fingertips to work with and use their data. And with that, I think I'm slightly over time. I apologize for going a tad long, but I will take any questions that you have.
Thank you, Justin. Hopefully everybody can hear me okay now. And again, we are a little pressed for time. So go ahead and take a few more minutes, let's say 4 more minutes for questions. And then we can just capture the remainder of the questions in the chat and pass them along. I'm not seeing any questions in the chat. Oh. And go ahead and Daniel Brown has his hand raised. Go ahead and turn on your camera.
Thanks, EB. And Justin, thanks for that presentation. It's we're at Oregon DEQ where I work. We're trying to move to more electronic data field collection or field data collection. And one thing that we've encountered is the maybe cost prohibitiveness of some of the user licenses and things that we would need for those Esri products. How are you able to, or what user type do a lot of the field crew need to have to be able to, access the field maps and Survey 123, and do they need different user access to use the web maps and things like that you showed?
That's a really good question. And I am not sure for Oregon specifically what you need. I think we just have, well, and in USGS, we all have just the default like pro user license, which gives us access to a lot of information. And so I don't know if I'm going to be the best one to answer that. But do you know Megan Kreutzberg with Oregon Institute for Natural Resources?
I'm not familiar, but I could probably look her up.
I'll post her name in the chat here. She works probably in a in a similar position that you do, and I think she'd be an excellent resource to contact. That she works on our project a lot, and all her crews have ArcGIS Online licenses, and so I will put her contact in the chat. She's really good. She's one of my best folks at providing feedback and making sure we make good updates. And so she really knows her stuff in Oregon in particular.
Great. Thank you, Justin. I really appreciate it. And those forms look amazing. So hopefully we can kind of duplicate some of the stuff you've been working on.
Yeah, and I'm happy to share any of that. And you saw we do work a lot with crews in Oregon.
Yeah.
And so, if you're interested in joining the RMP project, you can reach out to us. Jackie Couples is with Fish and Wildlife Service. She heads up the Oregon branch of all those and coordinates all those monitoring groups. And so you're welcome to reach out to her as well if you're interested in just participating in the program. It's not free. We do we have to charge something for folks to participate, but it tends to be a lot cheaper than setting up your own program as well.
Sure. Okay, thank you.
I'd also say one last thing on the user licenses, depending on how you do it, it is possible to make a fully public Survey 123 field form that then users don't have to have a license. They can download the app for free and they can use it for free. What we've done for other projects is created a password trick where they have to type in the right password to open up the form to prevent total public users from just entering random data. But that's worked very well and allowed users who don't have any ArcGIS on licenses to enter data for free without creating just this form that any random person could fill in.
Cool, thank you.
Alrighty. Anybody have any more questions? Throw them into the chat or raise your hand. And if you want to think about it, then throw them into the chat and we can pass those along to Justin. If not, we'll take advantage and I'll work on my audio. I apologize. Let's go ahead and move on to Brock Lipple with the Idaho Department of Fish and Game. And he's going to be talking about another mobile app which helps improve data quality assurance and quality control. And Brock Lipple, if he wants to go ahead and turn on his camera and microphone, Brock Lipple has worked for the Idaho Department of Fish and Game for 5 years and manages a small team of GIS analysts within the Idaho Fish and Wildlife Information System program. When he's not working, he enjoys the outdoors, playing music with friends, and spending time with his family. All right, take it away, Brock.
Hey, can y'all hear me?
I can hear you.
Perfect. Share my screen here. You see my screen now?
You can see it.
Oh, got a little ahead of myself. Okay, so my name's Brock. I work at Fish and Game. I've been here about 5 years, and one thing, I basically work in a small team of GIS folks for the whole state, and there's 4 of us, and a lot of what we do is, at least the past couple of years, is to move paper, traditionally surveys done on paper, to digital forms, and the tools we use are mostly Survey 123, field maps, and a slight parallel from Justin's is we have what we call ArcGIS Enterprise, which is basically a version of AGOL, so to speak, that we house on our own server. And so we basically manage the database from SQL Server instead of having AGOL manage things in their cloud space. And so today's talk, mine will be a little bit smaller in scope, so just kind of some practical examples about this form. And this is our first year doing this, and so we're certainly learning. And I even got some good ideas from Justin's talk. So these kind of presentations are pretty helpful even for the speakers. And so I'll do a really quick background, an overview of a data entry form that we started, and some things in there. And then we also have we just started using field maps recently, and then some QA/QC steps we do using ArcPro, and then attribute rules, which is basically a way to automate database triggers using spatial functions and things. So hopefully this is useful to some folks. And so the part of this survey is spawning ground application and database, and this is basically a central repository for spawning surveys in the state. And most of the work is done with Chinook salmon, but we can also collect other species. And so the goal of this project was to add an additional option from entering data into a database in an application at the end of the year. And so to basically have something that was a little bit more seamless, and then also allowed for better data access kind of in a middle step, which you might do before you actually submit data. And so we hope to improve the capture speed and accuracy. Certainly the data entry part is nice. Once you submit and you're done for the year, it goes into the database, and the data entry is a lot more minimal. And then maybe I need to move that. Sorry about that. And then integrate with an existing application, so we're not replacing an existing desktop app in database. We're just trying to do kind of a side project that would work between both. So just to visualize, this can be helpful for me. Folks enter survey data and use field maps, and that basically goes to our ArcGIS portal, which is our version of AGOL that we manage all of our users through. And so we have a single sign-on setup, and so anyone who's got a Fishing Game email can log in, and that's pretty helpful with our user tracking and things too throughout the year. And so in this middle space in ArcGIS portal, after data's been submitted, and basically like your first whack at it, you can then get to it in ArcGIS Pro and QC things kind of in that middle step before it actually goes to the central database. And so then we manage that ArcGIS SDE database where we're running our attribute rules, which I'll show. And then once that's all finished, and hopefully any errors are caught by that point, it'll then go to the existing application, which we might call like a legacy application. And so I'm really only going to talk about these first 4 icons here today. And Chris, who will be speaking after me, actually manages this section. And then Evan, who introduced everyone, is a data coordinator, and he kind of gets to it somewhere in this area also too. So common issues, these are like specific issues you run into with this survey. Wrong stream being selected. So if you like Beaver Creek, there's a lot of Beaver Creeks in the state. There's a lot of Silver Creeks in the state. And so Meadow Creek, sometimes people just pick the wrong stream. And so traditionally, if you just see it in a pick list, sometimes it's hard to know where you actually are. And if you can't see it spatially, it's hard to catch that error sometimes. Another issue is issues with waypoint management. And so naming of waypoints, or say you've been doing fieldwork the whole summer and you have a whole list of waypoints that you need to submit. Sometimes those seem to get mixed up, and you took waypoints from the Lemhi and put it on some other stream and attach that to your data. Certainly wrong points being selected. We have known starts and ends of transects. So you'd be on a stream and you'll say, I'm at this bridge, I'm at this tributary, which we already have in the system. And then certainly incorrect units and forms, pit tag entry errors, sample number entry errors, things like that. And then we have a lot of things we do after the fact where we basically sync points on a stream to our routing. And so we know how far up the stream from the mouth you started and where you ended. And so that would be the distance that you walked that day. But anytime an error is fixed, we have to run all those again traditionally to basically update those values. And so I'm gonna here and just a little short demo here. And so this is our spawning ground survey form. Let me make this a little bit here. And so just from the form itself, I mean, basically the first thing you get is ability to have autocomplete pick lists. And so we describe, what the stream is and what it's a tributary of. I mean, these are just easy things that just by going to mobile, you can have a lot more control over what they see. And then I've already filled this out, and there's a lot to talk about here, so I'm going to just kind of pop through here. But basically, we added a way to auto-populate waypoint names, and so you basically start with like a prefix. So in this case, I put my initials, and so say this is the start, but then I'll just move this down. Say you're going to collect a red here. It would automatically basically create a waypoint name, and then each red you collect is going to go up one number. And so this is a nice way to check your waypoints at the end of the road. And it seems kind of less important at the time, but it becomes more helpful in the end steps when the data coordinators are trying to make heads and tails of surveys they didn't complete, but they're responsible to check and run trends and things like that. And so certainly the required fields are helpful, and the waypoint management is pretty huge. And so each table is going to have a different waypoint name, and these will all go to the database into different tables, but you're a little bit more aware of what those waypoint names are. And then certainly this is a table to collect information on carcasses. And so an issue, and Justin's probably dealt with this, is that you have these things called repeats, and a repeat is just a related table that it's connected by a common ID. But in Survey 123, you go through each one, and so you'll cycle through, and you have to go to the first one, and then the next one, and then the next one. And so the way we got around that was, say you have an add clip fish, and then it's got another sample there, and say it's a pit tag, right? I have duplicates in here now, but basically it will just show you what you've done up to this point. And so before the user moves on, they can see the summary of the marks. And this is an issue we had sometimes with duplicated mark summaries. So we also had this on samples. And so if you collect multiple samples, like DNA or different things, this will also summarize that as well. And so it's just a way to have the users like, hey, is this what you want? And now you can move on. Something too, and this is actually something that I think Justin showed us, was we didn't have it this year, but for the pit tags, we have an app now that can basically paste pit tag readers information into this field here. And so that greatly reduces issues with mistyping, things like that. And then for the samples, we've generated QR codes for sample numbers. And I won't click it because it'll just show me on the screen, but now we can tie sample packs with IDs to the form without having really much intervention at all. So let me just pop this here now. And then certainly just simple things like summaries. How many reds did you collect on this survey? These are things that our users kind of asked for and they liked. And so we hope to kind of improve this over time. And then something in the background, we're also tracking device info. So as the previous speaker mentioned too, there's now we have new challenges, right? So it's like if you have a paper form, you could lose it or rip it or something. So now you have tablets and you can have bugs and issues with that too. So now we're tracking all the users, the device, operating system, what survey 123 version they're using. And so if we do have bugs, we can kind of go back and figure out what the issue might be. And sometimes we don't always know right away. So we're kind of constantly monitoring things. And so this was in case I think didn't work here. So we also developed a really simple field map. And so not all of our users use this year. And one question earlier was about licensing. And so we do have some limitations on licensing. So to use Survey 123 and field maps that are secured, you need to be a mobile worker license level. And so we have quite a few, but we only had so many. And so only a few users actually use this year. But we're not actually collecting data with field maps. We're just basically preloading offline areas of the common watershed boundaries that people are going to survey. And so this kind of helps with that awareness on what stream you're on, making sure it's the right one selected. And then this just helps with trails and things. A lot of these you might meet at a certain spot, like we're going to meet at this third ford, something like that. And so this just kind of helps folks as a companion to the Survey 123 app. And Survey 123 doesn't do the spatial aspects as well. And so this kind of bridges that gap. And so we could certainly connect them to, like Justin showed. So we'll have to see how we can implement that in a way that makes sense. And we can show transect boundaries. And so you can see where the end of the transect is. And that's another error. Evan mentioned an error that there's like an error that runs for a long time because it was done wrong the first time. And so everyone follows that method. And so they were maybe doing the wrong transect boundary for a few years in a row because that's what they thought was it, and it turns out it was something else. So this is a nice way to kind of fix that issue. And so after they've submitted data, this is something new we never done before, and so through our GIS portal, they sign in with their username, and so they can see things as they come in. And so this is reference data to SQL Server that's basically real time. And so they can go check the coordinator can check their work and then go see all their tech work and make sure that those all look correct also. And so we're tracking who's making edits, who's adding things. And so collecting device metrics, like I said. And so this is a way to catch a lot of the errors up front before it gets entered in like a tabular format incorrectly. And so even for us, this is kind of a big deal. So biggest challenge I think now with this aspect is getting all of our users comfortable using ArcPro, especially using relates and things. And so this might be an option, and then we'll probably implement some web apps and things too that might give a bit more of a tailored experience. And so something that's cool that's specific to ArcGIS Enterprise is these attribute rules. And so these are using Esri's arcade expression language. And so if you've ever used a field calculator, you might have seen it in there. But these are basically triggers using like Esri's proprietary stuff that will execute anytime a record is added or updated, in certain cases deleted, or even like in an edit session. You can have these things run all the time. So if anything changes, this will rerun again. And so you don't have to basically sweep back and fix things based on previous values that those are dependent on. And so some examples are we are interested in how far up the stream these started. And so we basically get an M value, which is like a distance, basically. It's some number. In our case, it's meters. And from the point of the stream, from the mouth up to the start of the transect and the end of the transect, or even just the walk. Transect might not always be the right word. We can also get the nearest stream. So what's the nearest thing to this point? And does that align with where you think you should be? And the only issue with these is these are done at a later point. And so these would help us. These would be like indicators that you would go back and say, hey, can you check this again? Another option is distance between start and end points. And so we do have examples where the start and end point might be the same if you're at like a weir, but an error we did see this year, and this might be an issue with the form we need to figure out, is that the start point and the end point sometimes are at the same location. And so now we can get an indicator that says, hey, are you sure that this is a single point? And so maybe even just implementing a category for if this is a weir, then that might kind of fix a lot of those issues. But this helps us ensure that you have correct lat longs for those 2 points. And then certainly you can transform coordinates to other systems. And right now they don't have projection features in arcade expressions, which is a little strange, but I've been able to do some conversions just using like straight up math. And so here's just a little example of what these attribute rules look like. And here's where you'd actually create them. So it's kind of similar to JavaScript, really. And so this left portion here, I'm basically taking a point that I've already converted to Idaho TM, and that's what our routing information is projected in. And then I intersect all the streams nearby using a intersect function and a buffer. And then I look at the stream that they've selected in the form, and if they match, then basically return the nearest coordinate to that start point, and then basically report the M value of that coordinate from the routing, but also I can get the distance. And so we can know how far the point is off the stream, which is a good indicator too. And so if you're a mile away from the stream you said you were at, or even 400 yards or 200 yards. In this case, I have this set to 200. That can be a good indicator that something needs changed, or maybe you had a poor GPS signal or something too. So a lot of reasons why these things can happen. And then this one on the right, this is just a portion of a script where I'm converting WGS 84 coordinates to Idaho TM, and it's a super long script, and I didn't want to show the whole thing, but you can basically just do all these simple math functions. And something interesting too is that Justin mentioned Python updating common values among all tables. And so when you're querying the data, and some of the tools can work a little bit more efficiently, you can do the same thing here. So I can basically bounce data from multiple tables to other tables. And maybe I have something that changes in a child table that's 2 or 3 away, and then that'll automatically go to the parent table if I add that as a condition too. So basically similar to Python, but sometimes a little bit more immediate if you don't have access to like a webhook or something like that. So here's just a really quick example of me moving a point down a stream. And I mean, you can even see that, so a lot of this is based on GIS data, and so sometimes the hydrography is not very accurate to actually where you are, and so we have to make sure that we account for those errors also. But you can see on the bottom right, it's a little hard to see, those last fields are changing based on that value. And so if someone's in there correcting a waypoint, all the things that I used to do manually, with sometimes with Python scripts or toolboxes, I can just set those scripts up to change as those values change. And so this really just kind of pays dividends at the end, especially at the coordinator level, or by the time those folks get to it, to sort of prepare things to send out and prepare reports and things like that. And with that, I think that is all I have today. My email is attached too, so if you have any questions about ArcGIS Enterprise setups or attribute roles, I'm happy to share my knowledge. And I'm still learning. This is our first year, and I think it went pretty well, but like Justin mentioned too, we're trying to take as much feedback as we can and not hide from it, and kind of make this something that our users will be excited about. And one thing I didn't mention too, in sort of this quality assurance space, is we have a yearly training, and so we get all of our folks together in one place, and a lot of our partners also, and tribal partners, and we go over a lot of these systems. And so when we have these meetings, we're going to integrate a lot more training onto the survey 1, 2, 3 aspects of it, and then certainly like how to access these, in the middle of the field season using ArcPro to sort of help you out later in the season when you're kind of scrambling to get everything entered by winter. So
that was awesome.
For questions.
Yeah, and we had been talking about the quality assurance part of everybody coming together with the common training and common protocols for collecting the data in order to reduce biases for both, everywhere from rookies to veterans of multiple decades. And that's a really important part of this, that the human factor. And Justin was also talking about that. Let's see. Anybody have their hand up? I don't see. I don't see anything in the chat.
Looks like Justin, maybe.
Yeah.
Justin.
So I've also, in addition to using ArcGIS Online, I've also have a couple of portal enterprise ArcGIS Online set up for different projects. And just curious about like your uptime and how hard to keep it operational in the cloud you found it, because we've struggled a little bit, especially when like my IT does updates and stuff. It'll tend to crash, and then we have to restart, and we have to talk to Esri. and it hasn't been as smooth as we'd like it to be. And so just curious what your experience is with keeping that enterprise server up and running.
It's really, we've been pretty lucky. I can think of a few times just the past couple years where it's gone down, and I think you nailed it. Like an update happens that maybe shouldn't have, or we weren't aware of. And our servers now are managed by a centralized state IT, but they basically inherited servers that we already kind of had built. And I would say that I'm pretty impressed with the uptime. And I'm usually pretty nervous around field season, like checking it every day. I have scripts too that like check, responses and things from the REST services. But I'd be happy to gather any more information I have. And what I know about it is that it's like distributed on multiple VMs. And so we have a machine that runs the Arc server portion. We have a machine that runs the SQL server. We have a machine that runs the web adapter. And so I don't know if that's kind of helped it have fewer issues, but certainly our contact at S3 is named Scott Moore. I don't know if he's assigned to your account too, but he's got a lot of information. So anything I can find, I'll send your way.
Thanks. And some of it might just be the USGS and DOI security. They love to block things in general, from my experience, and so that could be part of the problem too.
Yeah, we have had similar issues, not very often, luckily. It's like they kind of stop, but people turning things off at our IT location that don't think it's going to affect anything, and it does. So.
And then there's a question in the chat, Brock. It says, thanks. It's from Daniel Brown. It says, thanks for the presentation, Brock. Did you say that your surveys have a single user sign-in, so any IDFG staff can use them?
Yep, they do. So like the way it's set up is the first time, so we have a portal, like a website URL, so it's not AGUL, it'd be like GIS-portal, and it's I don't have it up, but you would basically click sign in, and then anyone who is a phishing game, has a valid phishing game email, is then now in the system. And Justin mentioned this earlier too, so that this first year we did a public survey that's basically secured by obscurity. So we haven't really had any issues yet, but our plan is to switch it over. So it really wasn't required for this year, but it will be required. But even if you are logged in, whether or not you have to be or not, then you can see who's making changes and creating surveys too. And so that means anyone in the phishing game can use it. We could also add built-in accounts. And so if we have like a partner who needs to collect a survey, we can then make them an account. And so something our state ITS is working on is a fix for identity management to basically work across organizations. And so we're hoping that we find a solution where we can work with our partners a little bit easier, also without making them like a built-in account. They could log in with their email or something too. So hopefully they'll cross that bridge in the next year or two.
Hopefully. And Brock, that sort of raises the question of, we only have like 4 more minutes, but that sort of raises the question, I think this is important, of how we could work with our collaborators in order to share our mobile apps, and what all did that take in order to do that?
Yeah, so we don't quite have this all figured out, but this year we shared, there's some issues with data ownership and governance from some of our partners, and so they want to make sure that their data is theirs at the end of the day. And so the way we did that this year was basically just have an identical form that they manage on their own AGOL system. And so we're just sharing basically the templates for these, and so they can collect data in our format, and then I append them in, but I do this manually. So we'll need to find a way to make this a little more seamless. But if they're using a common system or a common framework, it makes it a lot easier to basically get identical data tables into our system. And so one issue with the ArcGIS portal is that it doesn't talk very well with AGOL in terms of like user permissions and things. And so if a lot of our partners are using AGOL and we're using Portal, it's not always an easy way to transition usernames and credentials and things easily. So kind of a little caveat about that. But we also have AGOL, we just have fewer users. And so we have a federated server which can move things back and forth too. And so that kind of helps depending on what the project is and how secure it needs to be. And then we kind of make a decision on what role does AGOL play and what role does ArcGIS Portal play.
Thank you. Cool. Any other, Daniel, do you have a question?
Maybe one more.
Yeah, sorry. Kind of stealing a lot of the question time here.
Sorry.
Brock, how you showed an example of moving a monitoring location just towards the end of your presentation there. How do you track the reason and who made those changes so that you can tell from time to time if it keeps getting moved or it gets moved once so that you know when who did it?
The answer is that we don't yet. I can see that something happened, and I can probably create some other attribute rules, automated fields that can track what happened too, kind of like a change management thing. But we haven't implemented anything to say why something was changed. In this portion of it, there's a whole nother piece that I didn't show, which is the desktop app. And so this is, I would say this is kind of a light QC run through. And so a lot of the kind of the big changes might be at the other end of the end of the line too. And so
yeah,
that's a good question though. Something we should probably think about.
How about on the forms, like while the field crew is out collecting, if they, for example, they type in that there were 7 reds in a transect or something like that, and they need to say that it was actually 5 after they submit. Is there a way to track that? That's something that we're considering at DEQ here in Oregon.
Yeah, I don't know if it would track much. We do have, so there you can enable archiving. It's one thing, and there's also some version control things too. But archiving would basically keep a record of what if it say it was deleted or updated. It would keep like the version previously too, so you can go back in time.
Okay.
But for the form too, you basically would just resend a form, and at that point we wouldn't. It's kind of the user's workspace still at that point, and so we aren't tracking that at this time. We're just saying, okay, now there's 6, and whatever you say is good for at this point until it kind of goes to the next portion.
Okay, thanks. Appreciate it. Great presentation.
Yeah, thank you.
Thanks, Brock. Thanks for the questions, everybody. All right, next up is the second part of our solution for collecting, compiling QA/QC, managing, and giving access to our survey data. And it's Chris Harrington, who has worked for IDFG for the last 27 years as a fish marking supervisor, a active evaluation biologist, and then for the last 17 years, a software developer. In his spare time, he has hiked all over the country, and I mean all over the country, including both hiking and biking the length of Idaho. With that said, Chris, go ahead and take it away, please.
I'm going to be talking in a more general sense about designing user interfaces to improve quality control on programs. Not going to be using one specific program as an example, but taking examples from several programs that some people will find painfully familiar and some people have never seen. When people are thinking about QA/QC, a lot of times it's thinking about, okay, we have this data. How do we make sure that it is correct, that it's in good shape? But quality control begins a little bit before that. Another thing people are thinking about with QA/QC would just be making sure that you have the right fields filled out so that you have all of the information that you need. The quality control begins with the design of the user interface right from the start. One thing we've learned over the years at Fish and Game, and that we have forgotten routinely, is that you can generally predict accuracy of data down to the individual field level if you can understand how the person who's entered the data perceives the cost and the benefit of entering the data. Program can't really help much with benefits because the benefit of data entry usually comes sometime after the data entry. It might just be, I need this data later on, I need it to be correct, or I'm getting paid to do this, or somebody's going to get mad at me if I don't do this. So the benefits are all something that a program can't really help much with. They're usually later on. But a program can reduce the cost of entering the data. And if you can get the cost down so much that the benefits clearly outweigh it, then you're going to get good data. But if it's really hard to enter data, the benefits would have to be very high, or else people are going to make a lot of errors with it. So there are a lot of things we can do to reduce the cost of entering data. The first example I'll use is something that anybody who's been entering data and has been entering time or financial management in the state of Idaho in the last couple of years is familiar with, painfully familiar with. The first thing you're doing is guiding the user. And this is the first menu you get to if you're entering time in Idaho's new financial management system. And I think anyone can look at this set of options and see right away which one's time. Maybe not, but it's this one. And there are a couple things to say about this. This icon is actually pretty good. People are very visual, and if you can use an icon, it will draw people's attention to different pieces of the program. And you want that icon to indicate something about what this is going to do. And when it comes to time, there are two common images that we tend to use for time. One is the clock and the other is the hourglass, and they chose the clock, and that's a perfectly fine choice. I wasn't thrilled about the colors they used. I like to be a little more gaudy than that, but this actually would work very well for someone who's colorblind because you're seeing different shades of the same color. It should stand out fairly well. But then you should use the caption to further tell them that, yes, they're in the right place, this is the right thing to do. And what does this caption say to anyone? What's Infor WFM? Well, it turns out Infor is the name of the company that wrote the software. So they have very little space, and they wasted half of it saying their name. They could have said time entry or enter time or timesheet or something like that. And instead they said this. So they got the icon really well. They got the caption really poorly. Another example of that is this icon taken from a program that I wrote where captions didn't make sense. And so the icon has to do a lot of heavy lifting. And in this case, the icon is telling people either weight or balance. A pretty standard symbol for that. And from the context of the program, people would understand the weight. And since I can't use a caption, I need to be able to tell them what it is they can do with this. And so I use a tooltip. Drag to the rearing unit to enter weights for that rearing unit. It's telling you what you do with this and what you will get as a result. The nice thing about tooltips is you can be fairly verbose with them, and you should use them to explain what's going on, give some information to the user to let them know that they're in the right place and entering the right thing. But the problem with tooltips is that they aren't there right away. So if you can use a caption with an icon, that's better than a tooltip. But you can also do something like this. This is a example from a spawning ground program. And it's a button where the button's dealing with waypoint management. And the caption says waypoint management. But what icon makes sense for waypoint management? It's a very abstract concept. So I figured these people who are using this are going to be familiar with topo maps. And so the icon is a piece of a topo map showing a stream and a couple of points along the stream. So the icon draws their eye to the button, but it doesn't really tell them what to do because the concept's abstract. The caption then tells them, okay, this is what we want to do. And then the tooltip adds further information about what you can do with this button: load waypoints, manage waypoints, assign waypoints to surveys, etc. So you're drawing their eyes with the icon. You're giving them further reinforcement with what the caption is. And then if you have more information to give them, it goes into a tooltip, if you can have a tooltip. And you can't always have every piece, but it's useful for showing people things. The next example is another example taken from our time management. This is how you enter a timesheet. And the actual time would be off to the left. And that's just kind of your typical calendar control. It wouldn't surprise anyone. But then we have all these fun columns to enter: agency, project, org cost center, program, appropriations, fund, and location. And there are actually two more, but most people don't enter anything into that, and I didn't have room on the screen to show them. If these don't mean anything to you, well, they don't mean anything to anybody outside of accounting either. So you have to fill in these columns, and you have to get them right. They don't mean anything to anyone. What's really nice, though, is that we were given a lookup table, and we can enter one number, look up what values go into these fields, and just copy and paste them in here. The problem with that is that a computer can use a lookup table in a fraction of a millisecond, and it would be able to fill in all of these correctly in a fraction of a millisecond. Instead, the user has to either type everything into all these columns or copy and paste them into the columns, so that the best that the user can do is no better than what the computer can do in a fraction of the time. So the point is, we shouldn't be requiring people to do something extra. If you can get the data from any other means, then that's what you should do. Requiring people to enter data that you could get by some automated means that the best they can do is as good as the automated means, and anything less than that will be an error. So don't require anything extra of people. A corollary to that is look for efficiencies in the data, and this often doesn't work out, but I'll show you an example where it does work out. For spawning ground data, we're looking at the lengths of fish, and some people are measuring in centimeters and some people are measuring in millimeters. So originally I said, okay, tell me which unit you want to use and I'll accept whichever you want, centimeters or millimeters. What we found over time is that everybody screwed that up. It didn't matter how conscientious they were, at some point they would say centimeters and enter millimeters, or millimeters and enter centimeters. So one thing you could do is say, okay, it has to be one unit or the other. But if they aren't doing what they tell me to do, they certainly aren't going to do what I'm telling them to do. So instead, I noticed that for Chinook in Idaho, we never get a fish that is 130 centimeters long. We haven't even gotten close to that. We also never would sample a fish that is as short as 130 millimeters. In fact, quite a bit longer. Anything that short would be a precocial. And while we might get them, we don't bother sampling them. So I can say anything below 130, okay, that's centimeters. Anything above 130, that's millimeters. And I can use some more validation to make sure that it's actually in a range that's reasonable. But one of the nice things about this is that most of the typos that people will make will end up not having any impact on the data. For example, if they have a 95 centimeter long fish and they fat finger the last digit and type in 955, well, okay, it's an error, but it's half a centimeter. We actually won't pick that up. It's just not going to have any impact on the analysis. So in this case, I could say anything below 130 is centimeters, anything above 130 is millimeters. And I don't require people to get it right, which unit they're using. They can enter whichever they want. They don't have to tell me. I can figure it out on my own. So if you can find efficiencies in the data, That's great. But things like that rarely come up. The next point is consider the order of operations. For this, I'll use an example from Brock's mobile survey. We're asking things in a slightly unusual form. People are used to filling out things like this, and what you are used to seeing on numerous forms everywhere is who did it, when did they do it, and where did they do it, in that order. In this case, we're saying where up here at the top. We're saying who further down. We aren't actually asking when. But this gets back to not asking for things we don't need, because this is mobile survey, mobile data. We know when they collect it, as far as we care. We want to know which day they were on. And we know which day they were on because that's when they were entering the data. So we generally don't even care about when they did it. As for why we started with the where before the who, that was largely because this follows a format on paper forms that people have been using for decades. So anyone who's used those paper forms is used to doing things in this order. And so we followed the order they were used to. Another aspect of this is that this information is asked right at the beginning of the survey. That causes a few problems because everyone knows where they started a survey. They don't always know where they're going to end up. Usually they know where they're going to end up because they're walking from point A to point B, but sometimes there are two surveyors walking towards each other, in which case they don't know where they're going to end. They're going to end wherever they happen to meet. And so sometimes having the end name at the beginning doesn't work out well because they don't know where it is, and they have to come back and fill it in. So making it mandatory ensures that they will go back and fill it in. But it could also make sense to ask this information at the end of the survey. The problem with that is by the end of a spawning ground survey, people tend to be kind of tired, ready to head back to the barn, and they don't want to be sitting down and entering a whole bunch of data. And so we get this information right at the beginning when people are fresh and enthusiastic and ready to go. And if the order isn't necessarily perfect, it's better to get it early than to get it late when people are too tired to enter it well. So think about which order to get information, both individual fields, which ones you're going to ask for first, which order that people are going to be obtaining this information and ready to enter it, and also when they're going to be at their best for entering this information. Another point is try to provide visual feedback. And we actually saw some of this on the earlier presentations. I like using the stoplight method if possible. In this case, the sample method has been filled out. It's ground. And so this is green, all's well. The book number has not been filled out, but the book number isn't mandatory and a lot of people don't use it for anything. So I can't tell if having nothing is correct or not. And so it's yellow. It might be okay, but it might be worth a look. And the last two fields, they're not set, so they're red. At that point, a biologist said, well, could we add icons? It was kind of interesting. It was a female biologist, and that's a little unusual because women tend not to be colorblind, but she was absolutely correct. This probably would not work for everybody. They might not see the different colors between the different labels. So I also added a green check mark for when things are good. I decided to use a question mark for when things might be good, as it's unknown whether or not it's good, and there's a question about whether it's good. And the red X has become basically the default for this is not ready. This isn't good. Do something else. So people can see this form from across the room and say, oh yeah, I've got everything done, or I need to address these fields, or maybe I ought to address this field. And it just lets them know right away, good, bad, unknown, etc. Another point I wanted to cover is users do not read text. And this has been covered many times, but it's worth repeating. The simple fact is people don't read text. I do not follow this rule myself at times, but if you write more than a sentence, you can pretty much assume people aren't going to read it. And even if you write a whole sentence, people probably aren't going to read it. So maybe you have something where you really want to explain to the user, well, this is what you need to do. This is how you should make this decision. They aren't going to read it. You want to have just a very short 3 or 4 words at most, both for instruction and for error messages. And if you need anything more than that, it would be a manual, because if people aren't going to read it on the screen, but they might say, okay, I need more information to know what to do here. And that's when they would go to the manual. The people who are experienced with the program and know what they're doing, they're just going to blow through it. They aren't going to read even one word. They're just going to, in some cases, just click on the button because it's where the button was last time. So don't write a lot of text on any form. People aren't going to read it. Keep it really short. Keep it really simple, even if it's too simple. And don't worry about it being too simple, because if you need a really complex explanation, that's something for a manual. It's not going to be good on the form. It's going to cause more stress for people. It's like, well, should I be worrying about the little nuances tucked into this? No, don't have any nuances tucked into it. Just have a really short message. And it's a good idea to be somewhat lighthearted, especially with error messages. If you see Microsoft error messages, they tend to be completely opaque, just a number or something, and they're mean nothing to anyone. And you could be really wordy with error messages, telling people everything that went wrong and what they ought to do about it, but they probably aren't going to read it. So you should just keep your error message simple and send them to the manual if they need more information. But error messages especially will cause stress because people expected things to work and they did not work. And that's not going to make anyone happy. So being a little bit lighthearted with error messages is a good idea. So I had one program where you had to select fish, where you were going to move them from, where you're going to move them to, and somebody could screw that up by choosing the same source and destination, in which case they'd get this message. No need to stir the fish in place. It got the point across that they've screwed it up, but it should make them smile rather than upset anyone. So text on forms, keep them really short, keep them simple, even to the point of not being completely clear. Because if you need clarity, that's something for the manual. And feel free to be a little lighthearted about it, because errors are going to be stressful for people. And so if they are going to read it, make them smile. So, in summary, humans are really visual. Icons are really good for drawing people to what they're using. A lot of the controls that you see on forms in all these presentations, those technically are icons. They are drawing people's vision to, there's something I need to do here, or something I could do here. Guide them with both the images and the words to say what it is they need to do here. And this could be as simple as a caption on a text box. It could be as simple as a caption on a button. But if you can have both an icon to draw the eyes, a caption to explain what it's for, that's great. And then you can go on further with tooltips to give them more information if the caption alone isn't clear. Get only the data that is necessary. Anything you can get by automatic means, no matter how difficult, do it. If people are entering data that could be obtained by automatic means, the best you can do is not screw it up. And anything less than that is going to be problems with the data. So if you can get it automatically, get it automatically. And be fairly ruthless about that. Don't require anything that doesn't need to be entered. Look for efficiencies in the data. This rarely actually works out, but if you can find some pattern in the data that can help you figure out whether or not anything that's been entered is correct or what it means, then make use of that, leverage that to validate the data on the fly. But patterns in the data, they tend to be rare and fairly specialized. So it's worth thinking about for every single field, but you may not find anything in that. Consider the order of operations. Make sure you're getting things from the upper left to the lower right and in the order that people will get the information and want to enter it. Don't have them jumping back and forth across the screen, and get it the data when they're freshest. And whenever possible, provide visual feedback to let them know that things are going well or what things are missing. And other than that, have a good time with it. With that, I'll take any questions.
Thanks, Chris. That was great. A lot of useful knowledge based upon many efforts over a couple decades. Appreciate that. Take a lot of it to heart. Let's see. Anybody? It looks like Sam has his hand up. Or buddy.
Yeah. Hey, Chris. Great presentation. I have a question about the icons used to, help draw people to the right direction and whatnot. Do you have a library or a resource that you use to determine the icons, or is it kind of just this is what other people have used before, and I know a house means home and a clock means time?
Well, those rules are really good ones. I tend to work with things that get kind of abstract, like waypoints. I don't have any particular resource except the internet. I'm a horrible artist. So fortunately, there are a lot of online resources for images themselves. And sometimes it's worth just going to some online icon repository and just look through it and say, well, does that speak to me or not? So no, just the internet, I'd say.
In addition to that, I would second what Justin said about our users will let us know what worked and what doesn't work. We work with them extensively, and we encourage both positive and negative feedback. And so yeah, they'll let us know when something doesn't make sense.
I noticed that comment about the fun police. That's definitely an issue.
Mm.
We had a custom 404 error for Fish and Game that basically told people to step away from the computer, go outside and have fun. And that got slapped down. But you can also be on point and be a little bit subtle. There are a few of my error messages that are actually haikus. And you can be very much on point. They're short, they're correct, and the fun police will have fits with that.
Thanks,
Just
Chris.
trying to make QAQC a little bit lighter, maybe a little more interesting, which you could probably use. Anybody else have any questions? No. All right. If anything comes to you, then yeah, we do have contact information for everybody. So feel free to either put it into the chat now or just send it to us via email, and we will pass it along and make sure that they get back to you. Let's see. Any more parting words of wisdom from Chris, Brock, or Justin, or Sam, or anybody else? All righty. That's it for me. That's it for the presenters. I want to thank everybody for And I hope you found it useful, if not inspiring, and very interesting to say the least. That's it.
Yeah, thanks everyone, and a big thank you to the entire ETIS planning committee, which of course included Evan there, but is a big team of us. And I just want to let you guys know about next week's presentation. We're going to continue this ETIS webinar series, and next week we have 4 presentations on genetics, with the last one also being a traditional ecological knowledge presentation as well. So kind of pairing genetics with TEK. So come back next week, same time, same place. And yeah, looking forward to this, and great presentations today, everyone. And I will stick around for a little bit longer if anyone has any questions about this webinar series. Also, look for an email from me after this with the recording and additional information.